Groq query language in retrieval augmentation. Overview. Description. Groq query language GroQQL is a flexible and powerful language used for querying and manipulating data in content lakes or document stores. In the context of retrieval augmentation, GroQQL can be employed to efficiently retrieve relevant documents or data snippets to enhance the input for generative models. Key components. GroQQL syntax. Description. The syntax and structure of GroQQL queries, which allows users to express complex data retrieval tasks in a concise and readable manner. GroQQL supports a variety of query constructs, including filters, projections, and joins. Content lake. Description. A centralized repository that stores large volumes of unstructured or semi-structured data, such as documents, logs, and multimedia files. The content lake serves as the source of data for GroQQL queries. Retrieval mechanism. Description. The process of executing GroQQL queries against the content lake to fetch relevant documents or data snippets based on the input query. This mechanism ensures efficient data access and retrieval. Steps. Step 1. Description. Define query requirements. Identify the specific data or documents needed to augment the input for the generative model. This involves understanding the input query and determining the relevant data sources and retrieval criteria. Step 2. Description. Construct GroQQL query. Write a GroQQL query that specifies the criteria for data retrieval. This can include filters for specific keywords, projections for selecting particular fields, and conditions for data relevance. Step 3. Description. Execute query. Execute the GroQQL query against the content lake to retrieve the relevant documents or data snippets. This involves interfacing with the content lake's API or query execution engine. Step 4. Description. Process retrieved data. Process the retrieved data to extract the most relevant information. This may include parsing the data, filtering out irrelevant content, and formatting it for use by the generative model. Step 5. Description. Augment input. Combine the processed data with the original input query to create an augmented input. This enhanced input provides additional context and information to the generative model. Step 6. Description. Generate response. Pass the augmented input to the generative model to produce a response. The model leverages the additional context to generate more accurate and relevant content. Step 7. Description. Post-process response. Refine the generated response to ensure it is coherent and contextually appropriate. This may involve further filtering, adjusting for tone, and ensuring factual accuracy. Considerations. Query optimization. Description. Optimize GroQQL queries for performance and efficiency. This involves using appropriate indexes, minimizing query complexity, and ensuring queries are well-formed. Data relevance. Description. Ensure the retrieved data is highly relevant to the input query. This can involve refining query criteria, using advanced filtering techniques, and leveraging metadata. Scalability. Description. Design the retrieval system to scale with the volume of data and query load. This includes managing content lake performance, handling concurrent queries, and ensuring low latency responses. Security. Description. Implement security measures to protect the data in the content lake and ensure only authorized queries are executed. This includes access controls, encryption, and audit logging. Technologies. Content lake. Description. Use a scalable and efficient content lake, e.g., Elasticsearch, AWS S3 to store and manage large volumes of data. The content lake should support Groq or similar query languages. Indexing. Description. Implement indexing mechanisms to improve query performance. This can include text indexing, metadata indexing, and custom indexes for specific query patterns. API integration. Description. Integrate Groq with APIs to enable seamless execution of queries and retrieval of data. This includes interfacing with the Content Lake's API and the generative model's input pipeline. Integration. API integration. Description. Use APIs to integrate Groq with the retrieval and generation components, ensuring seamless data flow and interaction between different parts of the system. Continuous monitoring. Description. Monitor system performance, including query execution times and retrieval accuracy, to identify areas for optimization and improvement. Feedback loop. Description. Incorporate user feedback to refine query criteria and improve the relevance and accuracy of PE. Retrieval augmentation process. Example usage. Enhanced chatbot responses. Description. Use Groq to retrieve relevant documents from a content lake to augment chatbot responses. This improves the accuracy and relevance of the chatbot's replies. Knowledge retrieval. Description. Implement retrieval augmentation in knowledge management systems to provide users with detailed and accurate information based on Groq queries. Contextual document search. Description. Develop document search systems that leverage Groq to provide contextually relevant search results, enhancing the user experience in information retrieval applications.